Hello everyone. Today I would like to talk about technological features, key tools, and the architecture of the digital platform, Digital Q.Omnichannel, and the digital accelerators. The platform is designed to support quick creation and launch of digital services. First of all, I would like to draw your attention to the fact that the platform is based on the microservice architecture, and all of its components are represented by microservices of different types. In the center of this diagram, you can see the composable business logic layer. It consists of end-to-end cross-product business processes. These are microservices that ensure execution of the business logic in business processes. The other part is the layer of functional microservices that support such functions as a product factory or product catalog, the reference list of clients, the decision management system, and other functional microservices. The layer of cross-product processes is omnichannel, which means that access to the business logic is possible from any channel which interacts with the omnichannel layer of business processes. The platform supports all popular channels. It includes the online banking, branch banking, marketplaces, or a partner network, and any other channel. The entire business layer of the omnichannel platform interacts with existing bank systems, such as the processing center, data warehouse, general ledger, and others. The bank does not need to change these systems, as the platform is implemented above them and works with data that are stored in the existing back-office systems of the customer. On the left, you can see a set of low-code tools that allow the customer to develop the functionality of the platform, changing both the user interface and the logic of business processes. This includes changes in the data model and business objects that are processed in the system. Now I would like to focus on the platform technologies. This slide describes the key technological features of the platform. Let me elaborate on these features in more detail. First of all, I would like to talk about the presentation layer. Our web applications represent the thin client. These are single-page applications. They are built on the Angular technology. We use the micro-fronted architectural approach to build our web applications. Our mobile applications represent native iOS and Android applications. They are written in Swift and Kotlin languages, respectively. The back end of the system is represented by functional microservices written in Java. They are built on the Spring Boot framework. All microservices are packaged in Docker containers and are deployed in the orchestration environment, Kubernetes, or OpenShift. To support event-driven communication between services and other systems, we use the message broker Apache Kafka. There are microservices that are used to execute business processes, as was shown in the previous diagram. This means that within the platform, these microservices turn on the engine for execution of business processes, and the platform provides separate components for logging. This is the popular ELK stack. We also support our own solutions for logging, auditing, tracing, management of access rights, etc. To support access to the functionality, we use the API gateway approach. We can use a single gateway for the access to all functional capabilities or install several gateways. Each of them will physically restrict the access to specific functional capabilities. We have discussed the general architecture and technologies of the platform. Now let us switch to the toolkit that supports capabilities of Digital Q Omnichannel. First of all, this is the Business Process Management System, Digital Q.BPM. Another important tool is the design system, Digital Q.Palette. The third one is Digital Q.Sensor for the real-time analytics. The two basic principles used in our business process management system are the centralized management of business processes and the decentralized execution of business processes in separate microservices. Execution of business processes in separate microservices allows us to leverage the benefits of the microservice architecture. They include the fast time to market, the ability to quickly update, the ability to reuse separate components, independent scalability, and high fault tolerance. To support execution of business processes and their parts in separate microservices, we need to provide a centralized point for access, management, and monitoring of all these business processes. This is important for the microservice architecture, and our Digital Q platform provides such a point. The Business Process Management System provides a single catalog of all business processes of the organization. It contains convenient tools for structuring of these business processes and providing access to them. The platform also contains design tools for creation and editing of business processes and their publication. All actions on business processes are done in the Business Process Designer. We also provide a centralized monitoring system. It is important for us to know what is happening in all processes, all microservices of the platform. The functional capabilities of the platform include management of the following 3 components. These are business process, business rules, and user tasks. A business process is represented by a diagram in the BPMN 2.0 notation, which is widely used in the industry and which actually represents an industry standard. The platform supports automatic validation of BPMN diagrams. To ensure integration, the platform supports both event-driven interaction and direct interaction via the REST and the SOAP protocol. The event-driven communication with the business process is supported with the help of Kafka. The event-driven exchange and direct calls are used not only to support communications with external system. The processes themselves can be launched by an event received from message brokers and through a REST call. The platform supports version management of all business processes. All process versions are shown in the Business Process Designer and in the monitoring system. This capability is supported both in diagrams of business processes and diagrams of business rules. In case of business rules, the platform uses the DMN notation, which is also widely known and popular in the industry. It is used to design both trees of business rules and decision-making table. For design of business processes and rules, the platform supports usage of script expressions, written in scripting languages. The platform supports several of such languages. Business rules can be seamlessly integrated into business processes, which expands the functional capabilities of the BPMN notation with the functions of the DMN notation. Let us switch to user tasks. This functional component allows us to involve users in the automated business process. The system provides a single point of access, that is the centralized user interface for work with user tasks. A user always sees all tasks that are assigned to him, his business unit, or role. If the user starts processing a task, he works in the specialized interface, specially designed for this type of task. All tasks are created within respective business processes, in separate microservices. The system supports different algorithms for assignment of user tasks. A task can be assigned to a user, a role, or a user group. It can be also assigned to a business unit or a department. Based on the selected algorithm, the system can automatically define the user with the lowest current workload and assign the task to this employee. This screenshot demonstrates the standard interface of the system. Of course, we cannot show all features and special functions here. The main functions is the visual design of business process, with the use of the popular notation. Exactly the same editor is used for business rules. Everything is designed visually. Significantly, the platform can be used not only by technologists, but also allows involving business analysts and end users in design of processes and rules. Ideally, the business user together with the analyst creates a high-level design of a business process. Then, the analyst enriches the description of the business process with details. After this, the technologist adds technical features to each node and starts execution of the process. The monitoring scheme allows viewing all processes in the system. It also allows tracking how each process was executed in the system, with all information is presented in the visual form. The user can see which branch of a process was executed and which parameters were used at each node of the process. That is, the platform provides all tools for the analysis of executed business processes. The next slide refers to the user interface. It is managed in the digital Q.Palette platform. The platform provides tools for design of both the initial design of the user interfaces and for its further development. It is also used for automatic deployment of the user interface in a microservice environment. From the point of view of technology, we use Angular as the main framework for web applications. We also support implementation of applications based on React. The main language used in the system is TypeScript. Mobile applications are developed with the help of Swift and Kotlin. Digital Q.Palette provides tools for design of ready applications. These are standards and templates for design of user scenarios, UI, and UX. Another tool is a palette of design components, which is provided as a Figma library. A designer enables this library and starts designing interfaces in accordance with the approved design system, which determines the color palette and the available visual themes. During the design process, the developer can verify the creative design using special tools for validation of Figma layouts for compliance with the approved design system. For the development of web interfaces, the platform provides archetypes that are used to create templates of web applications. These templates are used in the toolkit that allows generating web interfaces based on the Figma layout. That is, the user creates a Figma layout, starts generation of the web application, and receives a ready-to-use web application. The platform provides a component-based palette for the software developer. This palette fully corresponds to the palette that is used by the designer for design of interfaces. This means that the ready interface will fully correspond to the layout created by the designer. In addition to the component-based palette, the platform provides a set of system functions and system libraries. They facilitate the development process and automatically fulfill basic tasks that are not related to the logic of communication of interfaces. The tools for the deployment include a specialized microservice that is used to package the created web application. This application is then deployed in the orchestration environment, Kubernetes or OpenShift. After this, our user interface becomes available in the user browser. This is the step-by-step process. Firstly, we create a design in Figma. Then, using Digital Q.Palette linter, we check if the created design corresponds to the selected design system. After this, we generate and finalize a web application or a mobile application and launch the pipeline for the assembly and delivery of the application in the user browser or mobile device. The next part of my presentation covers the platform Digital Q.Sensor. This solution is designed to receive real-time analytics on the processes running in the platform. Digital Q.Sensor works with all data received from the Digital Q platform. In addition, to create analytical dashboards, the system can use data obtained from any other system and any database, depending on what dashboard we need to create. The platform includes data visualization tools. It is a large array of 2D and 3D diagrams and charts of different types, including geographic maps used to build diagrams based on geodata and be able to track what is happening in different regions in different branches of our organization or bank. All dashboards and graphs are interactive. They support zooming and drill down functions. That is, we can start the analysis from the high-level data and gradually go deeper to the most detailed data until we understand what caused the current data, what has happened in our business or in our processes. Digital Q.Sensor is a lightweight system for generation of real-time analytics that does not require large investment for implementation. The platform provides a set of templates for creation of standard dashboards for different industries, including banking. An organization can immediately start using such dashboard templates and graphs with minor customization. In addition to ready-to-use dashboard templates, the platform provides low-code tools for design of such dashboards and diagrams. This means that the business technologist can set up necessary dashboards without coding and visualize data received from the system. Besides the ability to visualize data is separate dashboards that are linked by some business logic. Dashboards and charts can be integrated directly into the user interface. This helps to draw the user's attention to specific metrics. For example, with these dashboards, the user tracks how successful he or she was in the sale of loan products during the current quarter. Digital Q.Sensor consists of two main components. The first one provides visualization tools, which are responsible for the presentation of data and dashboards for the user. The second component is the dashboard designer, which provides the low-code development toolkit for the technologist. This toolkit allows setting up the required diagrams that are later displayed in the dashboard to the business user. This is an example of a diagram created in the platform. This dashboard combines several graphs of different types, which are interlinked with each other and present data for different analytical dimensions. The data can be displayed as a table, and the user can analyze metrics from different sides in a single screen. We have talked about the architecture and the technologies of the platform. Now, let me show you how these features influence the performance of the platform. Together with the companies IBM and Red Hat, we have completed a joint project for benchmark testing of the platform. The testing was done in the IBM data center in Montpellier, France. The goal of the testing was to determine the performance of the digital platform under the workload typical of large and very large banks. The objects of the testing were multi-component applications built on the Digital Q.Omnichannel platform. They include applications for online banking, mobile investment banking, and the loan origination system. All platform services were deployed and managed by OpenShift platforms for orchestration of microservices. They were deployed on IBM servers. These are the results of the benchmark testing. The total number of users registered in the system was 20 million, with 100,000 users working concurrently. The stable operation of the system was proven under the load of 1,000 transactions per second. That is, the system was faultlessly processing 1,000 requests per second. The benchmark has proved the highest performance and fault tolerance of the system. The proven performance was achieved on IBM servers under control of the OpenShift platform. Within the project scope, we defined the best configuration of the systems required for stable operation of highly loaded systems typical of large organizations. In the last part, let's talk how the platform and solutions based on the platform can be deployed for the end user of the company. The platform is built in the cloud-native architecture. This means that it can be deployed both on-premise and in the private or public cloud. The most popular examples are Google Cloud and Amazon Cloud. Let me summarize all said above. The Omnichannel platform is a fully microservice platform. All its components are microservices, starting from the front end to all functional microservices. The platform provides a wide range of low-code development tools that allow customers to develop the functionality built on the platform. All tools complement each other and interact with each other. The solutions built on the platform guarantee proven performance and fault tolerance. Speaking of our approach to the digital transformation, the Omnichannel platform does not require replacing large functional blocks or all existing functionality at once. Our approach is based on the step-by-step replacement of the most critical business functions. We develop and implement one functional block and then move on to the next block that is the most important for the current business needs and digital transformation tasks. These are the key technological features of Digital Q Omnichannel I wanted to talk about today. Let me conclude here and thank you for your attention. If you have any questions, please contact us at digital@diasoft.com.